Hi everyone, I'm Jim Cahill with another Emerson Automation Experts podcast. Wireless technology has enabled amazing advances for everyone across the globe. While the technology is solid, there's still room for improvement. Communication engineers battle with challenges such as Wi-Fi coexistence, multipath fade, non-deterministic data reception, and obstructions, all that may affect reliability. You may have heard the recent news about Emerson's corporate venture capital business investing in the Austin, Texas-based company's Spearix Technologies. Their adaptive multi-core radio processing technology provides a system-level solution for industrial Internet of Things, or IIoT, wireless communications. Today I'm joined by Spearix Technologies' Juan Conchas and Emerson's Laura Schafer to discuss the technology and how Emerson looks to expand its IIoT technologies as part of its pervasive sensing strategy. Welcome, Juan and Laura.
Thank you for
Thanks,
having me.
Jim.
Well, it's great that you're both here. So I guess to kick things off, Juan, let's begin by asking you to share your background and path to your current role at Spearix.
Right, thank you. So thank you for having me, Jim, and I'm very happy to be here with Laura also. My background is technical. I'm a BSEE from MIT, and my first job out of school was at Maxim Integrated Products, which is now part of Analog Devices. And I was very happy to focus more on analog and mixed signal early in my career, and I got exposed to customers very early on as an applications engineer, and so I decided to split my career into customer-focused marketing and business as well as technical. So my career has been half technical and half business the entire time. And I've worked for such names as Xilinx and Silicon Labs, Micrel, Microchip, and most recently Abercon, who is a supplier into the Internet of Things. My background is not wireless, and it seems ironic since I'm here at Spearix as the VP of Sales and Marketing, but my background is more wireline and SerDes and high-speed communications. But I think I bring a fresh look at wireless, and that's something that Spearix is doing, is taking the tradition of wireless engineering and bringing in new tools and new technologies. And I'm happy to be here and discuss all of these things.
Well, that's a great and widely varied background. It's going to be really good for our discussion today. Laura, let me turn to you, and can you give us a little bit about your background and path to your current role?
Sure, Jim. So I got my technical degrees from the Colorado School of Mines in chemical engineering. I got my bachelor's and master's, and then joined the oil and gas industry. I worked with oil and gas for 10 years upstream, and that's where I got my first exposure to Emerson products. I was using a micromotion Coriolis meter to measure additive addition to frac fluid. So that's how I got introduced to Emerson. And then I joined Emerson in 2012 in a business development capacity, got to really meet a lot of customers and see how they use Emerson products. In 2020, I joined our digital transformation group, and that's where I really got into Emerson Wireless and our wireless heart technology that we offer. And since then, I'm now the Vice President and General Manager of Pervasive Sensing and Connectivity in our Measurement Solutions Group up in Minneapolis. And really happy to have Spearix with us today to talk about the technology that we're excited to integrate into our products moving forward.
Well, that's really great, the pervasive sensing and this wireless technology, because that's really the heart of a lot of this sensing, just to be able to get so much more and then make use of it in your digital transformation. So, Juan, let's get into it a little bit. Let's talk a little about radio frequency, or RF, adaptive diversity technology. How does this communications technology make wireless more reliable and predictable?
We have the intuition that wireless can only be pushed so far. Wireless as a physical connectivity suffers from things such as obstructions, multipath fade, reflections, interference. The wave can interfere with itself, and all of these things are subject to environmental conditions. And no matter how good a single connection is, there's always something that can prevent it from being 99.999 or 100%. And so one of the ways that we are making wireless reliable is by adding what we call diversity into the mix. And we're doing something unique that is part of our patented technology. We are applying multi-core RF. So for the first time, we see a need to use more than a single radio, more than a single core. And what the multi-core RF does is it builds diversity by applying multiple modes of what we call frequency, time, and space. In other words, there is more flexibility when you have more cores, and the time, frequency, space coordinates that you select to propagate that connectivity builds immunity. And as it builds immunity through the air, we call that gain. And so the multi-core radio regains capacity with gain by using diversity through the air.
Yeah, that sounds like, even in biological systems, greater diversity means greater resilience. So that's really interesting there. Since we're now recognizing that RF environments can be corrected using this diversity, what are the impending challenges that this technology helps solve?
Yeah, so there are impending challenges. Probably the biggest one is interference, or what the industry is calling coexistence. We haven't seen enough coexistence issues yet because as much wireless as has been deployed in the industry, it's not 100% ubiquitous. And the promise of the IoT, the industrial IoT, is just a subsection of it. The promise of the IoT is that we are going to have hundreds, thousands more wireless devices around. And all of these devices are contesting for airspace and bandwidth and spectrum. And that is going to inevitably create interference problems. And so what the diversity does is it addresses the fact that interference is location, frequency, and time-based. It's not constant throughout. And if you can discern the best way to apply those things, you can solve the interference problem. The next challenge that's coming is planning and placement. So the IoT cannot be isolated to certain conditions, to certain spaces. There may be sensors that need to be at ground level. There may be sensors that need to be up high or behind a set of obstructions. They might be mobile. Because of all of those infinite ways that sensors need to be deployed, in order for a ubiquitous system, in order for a system to really have the freedom and the degrees of freedom that it needs in order to be ubiquitous, then you have to release it from this planning constraint. And so space is, where something is located is another challenge. Third is a challenge of longer and more predictable battery life. Longer and more predictable battery life means that you need to have a consistent reliability of your wireless. If your wireless tends to retransmit much more often than it's supposed to, or much more often than you expect, then you actually shorten the battery life. And so predictability of the wireless and the wireless reliability becomes important, so that you can actually plan, how much battery do you need? How long is this sensor going to take? If your sensor life falls short, then you have unplanned maintenance that you have to do, go replace batteries or take the sensor down. The sensor doesn't operate long-term enough. Battery life is becoming one of the most important things.
Yeah, that makes sense that, if you have to keep retrying, you're working it's having to communicate out, you're burning battery doing that. So yeah, I can see that predictability being an important thing. So Laura, the future of industrial IoT may rest in solving this interference and the sensor placement and density, as well as increasing battery life. What do you think is the business impact on industrial installations as these capabilities are expanded and ready for the future?
Yeah, so customers have not run into these issues quite yet. We are anticipating that as customers are going through their digital transformation and have to instrument more and more spots in their facility, they need wireless. They need wireless to do this. And for many customers, they've dropped in maybe an initial network, the initial set of devices, but many customers need lots more devices. And as they do this, there are challenges that we know are on the horizon that we want to be in front of with this technology that Spearix is bringing to the table by offering that increased reliability to make sure that the signal gets through the first time and you don't have to retry to get that signal through. That's going to help the reliability, not just of the signal, but of the battery life also, as Juan mentioned. So I think that by working with Spearix, we're getting ahead of these challenges that customers will have as they put more and more wireless in.
Yeah, that makes a lot of sense. It's just that every device, everything out there is becoming smarter and smarter and wanting to communicate and say what's going on. So to sit here today and look at how much it's instrumented, just looking out 5 years from now, it could be way more just because of so many more smart things in the plant, especially as we move towards more autonomous operations.
Absolutely.
So Juan, how is this technology independent of spectrum, protocol, or bandwidth? And what are some of the wireless standards that it'll work with?
One of the challenges that was posed to Spearix when we first started working with Emerson as an industrial partner is the need for backwards compatibility and the need to be able to just roll into what has already been taking place over the last 10, 20 years in wireless. And as Laura said, this is a future need. It's not necessarily here yet. So in preparation for that, we can't overhaul the network in order to accommodate this new technology. So we had to come up with a solution that was backwards compatible and spectrum compliant or compatible with the same spectrum. We don't want to jump to a new spectrum either. Many wireless technologies, especially in the startup phase, they have a tendency to require a new protocol or a new spectrum, and we definitely wanted to avoid that. So in doing that, we adapted our technology very naturally. It naturally adapts to this to meet backwards compatibility in protocol. Any protocol actually will work. We can apply our radius diversity to any protocol. There are some protocols that will benefit much more than others, like narrowband and battery operated low power, which is exactly what IoT and industrial sensors need. But synchronized networks especially, and in fact wireless HART, which is the preferred standard within industrial, was a shoo-in for what we're doing. So wireless HART works very well. Wireless Heart happens to be a IEEE 802.15.4 based solution, so it shares a lot of commonalities with other high volume standards that are also in the 2.4 gigahertz space, such as Thread, Zigbee, and eventually BLE. But as I mentioned, we can also be backwards compatible to other protocols such as LoRaWAN or some of the sub-gigahertz like YSUN, et cetera. We really are independent of the protocol itself. We just have to apply our technology to it. We're also independent of spectrums, so 2.4 gigahertz and 800 megahertz, 900 megahertz, sub-gigahertz will also work with us. And in the future, many other standards could be 5 gigahertz or even higher frequencies.
So that flexibility, that is pretty powerful, especially the backward compatibility for all the years that the wireless devices have been out there. So Laura, what was it about the Spearix technology and their team that made us want to make a capital investment in the company through Emerson Ventures?
Yeah, the backwards compatibility is incredibly important because we've got over 500,000 devices out there ourselves already communicating wireless heart. So the ability to take the additional reliability and potentially additional range that the Spearix intellectual property offers and provide that backwards into existing networks is incredibly exciting. So backwards compatibility for one. Of course, all the value messages that the technology brings on range and battery life and reliability are very important. So that's one of the primary reasons, was jumping on that intellectual property and helping guide the team into deployment of this in an industrial environment was first and foremost why we wanted to jump on this. The team, of course, they bring a lot of experience on how to deploy this, and they're bringing expertise on wireless heart as well to the table, so we can work with them to make sure that this is the right solution for our customers. We are very interested about the application to other protocols as well, other environments. There's definitely substantially more volume in the commercial market, so adapting this technology into the commercial markets offers a tremendous opportunity for folks, beyond just our industrial customers.
Yeah, and if you look at how digital transformation and other things, you're getting a blurring of worlds anyway, that there's a lot going on in the commercial space with sensors and other things in the industrial space in there. So, yeah, I see that. So, Laura, with the current portfolio of intelligent devices communicating with each other and host systems with wireless heart, the mesh-based communications technology, how will the mesh combined with Spearix adaptive diversity technology help to increase communications capacity, visibility, and reliability?
Sure. So down the line, we need to continue to work with our team, our engineering team, and with Spearix to reduce the cost of wireless infrastructure. And by deploying this technology, we're going to be able to potentially extend the range for wireless heart communications between where we put our access point, where the devices are. So as we increase range, we are also looking to increase the total device count that can be handled on an access point. So a customer that in the past might have needed many access points to bring in a few thousand devices can get away with fewer access points, reducing their overall infrastructure cost to deploy a wireless network. So ultimately, we're going to be reducing that cost for our customers and helping wireless be deployed truly pervasively, because it's not been pervasively taken up to date.
Yeah, so it sounds like lowering the infrastructure costs of it and actually extending the maintenance, because if these are more efficiently communicating and not having to retry kind of thing, longer battery life. So yeah, there's a lot of good in that. So Juan, I was recently reading the white paper you released on the website about the Radius wireless physical layer solution. Can you give our listeners some insight on how it discerns the environmental radio frequency conditions and adaptively controls RF communications?
Sure, thank you for asking that, Jim. The white paper is available on our website, Spearix.com. What we are able to discern is, as data starts coming in, because we have diversity, we're able to discern what we call colored packets. So when packets come in, they don't come in 100% clean. Some of them are colored with things that are environmental, such as obstructions, such as reflections, or other environmental conditions. As those packets come in, we consolidate them on the back end and then make decisions based on those environmental colored packets. And those decisions let us adaptively tune our time, frequency, space coordinates of the multi-core radio in order to more effectively cut through those aggressors. And we're able to go through aggressors that a single radio core cannot go through. And the best example is, for example, coexistence. Coexistence, as Laura has mentioned, it will be a big problem if it's not dealt with, and so many ubiquitous radios or wireless are all contending for the same spectrum. We can tell when a packet comes in if it's hindered a lot by interference. We take a look at that channel, or it could even be that time slot, or it could even be that space connection between one core and another core on our wireless, and we can jump to a different time space or frequency space coordinate, for example, where those packets are not colored by that interference. So we have much more flexibility to make those decisions than a single core wireless does. A single core wireless basically has to live with its own frequency space or time space or frequency. It only has one choice of frequency, basically. So because of the diversity that we built, we're able to jump to different time, frequency, space coordinates that can cut through either the interference or whatever other aggressor is out there and build back that diversity for that channel.
It's kind of playing air traffic controller and say, okay, we need to skip over here. This will be better for us. That's really cool. So how does this adaptive diversity technology reduce communication packet error rates, reducing those retransmissions, which helps with battery life?
One of the challenges with wireless today is that there's really only one way to rebuild that channel capacity because a single core only has one option. When the packet doesn't make it, it needs to retransmit. So the retransmissions are actually hindering battery life because there is no guarantee that the next retransmission is going to make it, and then the next retransmission might fail again. So that wireless doesn't really have any idea or can't really compensate to make sure that the retransmission has a much higher likelihood of making it. So the way that our diversity builds or lowers power is by making sure that at any given point it uses the best time, frequency, space channel or coordinate that has the highest likelihood to make it through. And by relying on that highest likelihood, then the likelihood of needing another retransmission is much lower. So even if that time, frequency, space coordinate or channel requires slightly more power, it still saves power by overcoming the aggressors in the air. And then we also have data, and it's in the white paper. We also have data that shows if you use the right time, frequency, space combination, you can actually get away with lowering the transmit power. So you save power not only because you become more reliable with fewer retransmissions, but your overall transmit power can actually become lower, something on the order of 10x lower. So you can imagine that your battery life can be highly extended. It also has the benefit of quieting down the entire network, because each RF link knows where to operate as far as optimal connectivity and optimal likelihood for the packet to go through without, screaming up at a very high dBm, which is what most wireless just does today, is
Crank
it to the highest.
Yeah. Listen to me, listen to me.
Yes. Yes.
It's just a fascinating technology. So Laura, how do we envision applying this technology in our products?
Sure. We like to start by putting it into our access points. That is the first place where we can maximize impact to the customer. By simply changing out an access point in an existing network, could have a step change in reliability and potentially distance as well. So that's the first place that we would see to do it. Then we would look at adapting the technology into next generation devices as well to get the benefits on both sides of the transmit and receive, and just build a substantially more reliable network across the board. So start with the access point and then move towards the devices.
Okay, I'll save the when question for a future podcast then as this develops and go forward there. So, Juan, what are some of the performance gains in this technology over what we have today?
Sure. Another great question, Jim. Thank you. So, we see the technology as mining capacity, where a single core radio or a single core wireless does not have the option to select an arbitrary or more time, frequency, space channels to go through. The more cores you add, the more flexibility you have in choosing that time, frequency, space coordinates. You could choose 4, or if you have more cores, you can choose 8 or 16, and thereby mining capacity or having much more capacity than a single core can take advantage of. That capacity can be used either to improve overall data rate, or it can be used to improve battery life. You transmit at lower power. That's one aspect of it, or higher reliability, fewer retries. So it's all two sides of the same coin, even though I just mentioned multiple sides. But once you understand that you're taking advantage of more capacity than a single RF core can take advantage of, then you're free to optimize your performance. So we've seen gains in, there should be gains in distance, there should be gains in reliability, there should be gains in power consumption. Where you should apply this is in contested environments that are very hostile to wireless signals and that require extended battery operation. So if you look at our white paper, you'll see that we make a case for, in most cases, transmitting with very low power, 1/10 the power, and you still get 96% reliability or 96% throughput on any given packet. And so we see that as a big gain for wireless.
Yeah, it certainly sounds like there's a number of different dimensions where you get that performance increase. Well, it's been a fascinating discussion. Let's wind it down here. Laura, are there any closing thoughts or things you want to add for our audience that we haven't talked about?
Well, I think just in general, we're really excited about the future of wireless for our customers. Just there are so many more points that need to be measured, especially as we just came through COVID. We've got a lot of customers who realize the need to provide more data to folks who are working remotely, to automate operator rounds and give us visibility into the maintenance or monitoring applications that just have never had the attention in the past. So we see big growth for wireless in the future, and improving the reliability at the battery life, et cetera, is where investments in companies like Spearix are really important to move the technology forward. Now, we see this for the industrial environment, but the technology that you guys are bringing to the table has tremendous opportunity for commercial and residential applications as well. So we're really excited to be partners moving forward and help get you the exposure to some of these other markets as well. But really excited to have this opportunity to speak with you as well, Jim. There's so much to be excited about in wireless.
Yeah, and it just seems like, at the recent Emerson exchange, talk of autonomous operations, and it just seems like you'll have to have way more sensing, way more things going on, the more you can move down that path towards autonomous operations. So Juan, how do you envision this technology unfolding over the next several years?
So, very, very new technology. We are just getting started in understanding what this technology can do. I mentioned we're mining capacity. I mentioned multi-core wireless. I think we started with the right partner. I think that the leader in industrial wireless is probably the premier first mover of what this technology can bring. So thank you for partnering with us. And but that's only the start. I think that there are many things that can happen once you understand that multi-core wireless actually can do things that a single core can't. We've been already discussing internally, also with Emerson, that it might even change the wireless game from a dB race, where it's dBm sensitivity, dBm output power, and it's all about cranking up the power and cranking down the sensitivity, and that makes a better link. We don't know that that's the right way to go anymore. It might actually be more cores rather than a dB race. So it might change the way that wireless is designed. There's also this aspect of today we have to go after very high-end applications that really require or really benefit from the reliability, right? Industrial is a great example, especially moving forward as wireless becomes ubiquitous. Industrial at some point in the next 5 years had to address the new coming challenges with something. We're glad to help, but as Moore's Law and other things take over, we believe that the other more volume-driven markets like home automation and maybe even consumer markets will be able to benefit from this technology. So we're starting at the very high end of the requirement, and eventually everybody should be able to use some form or another of a multi-core RF processor.
Yeah, it just seems like if we get all these smart devices whispering to one another, the battery life's going to extend, and plus lower all the EMF that's floating around among us. So that sounds like a great thing. Well, I want to thank you both so much for sharing your thoughts with our listeners and viewers today. And I guess if you want to learn more about the technology or read the white paper that we alluded to, visit the Spearix website at spearix.com. Thanks everyone for joining us.